if you don't have this dot plot made, make it, because we are going to be referring back to it like throughout the whole lesson. So today we're going to talk about transforming data with arithmetic operations, which just means multiply, subtract, add, divide. So we're using arithmetic. So we're going to take the same test scores and we're going to find the z-scores. So remember last time we practiced finding z-scores, and off to the side I'm just going to remind you z-scores were found by taking your observation minus the average divided by the standard deviation. So we're going to take these test scores and we're going to transform the data into z-scores and see what happens to our dot plot. So the first mathematical operation involved in calculating a z-score is subtracting. So we're going to take the individual score and subtract the mean. Now the mean had a decimal, but for the purposes of this lesson, we're going to get rid of the decimals so that we have pretty numbers. And we're going to say the mean was 80. If I remember correctly, it was like 80.1. But then we're going to have a bunch of decimals, so we're just going to say it's 80. So we're going to fill in the table, and then we're going to make our dot plot. And I'm going to fill in the first couple of lines on the table, and then you guys get to take over. So you're going to take the score minus the mean. So 61 minus 80 would be negative 19. 68 minus 80 would be negative 12. If you don't want to put the actual score minus the mean and you just want to put the answer, maybe if I can do that. There we go. That's fine. You don't have to show it. You can do all that in your head. Go through, fill in the rest of the scores minus means, then create your new dot plot. Questions? You guys all know what you're doing? Kyler, put the phone away. Thank you, sir. Bum, 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 bum. Oh, come on, computer.
Yeah, I turned it on. Oh, okay. Oh, thank you.
All right, Molly's gonna fill in the rest of our table and put our new dot plot up. Thanks, Molly. All right, so we have, I'm going to zoom in a little so hopefully you can see. So your score minus the mean, she filled in the rest of the table, created our dot plot for us, and now we're going to compare it to the dot plot from the warm-up, and I want you guys to think about what happens to the shape of the dot plot, what happened to the center of the dot plot, and what happened to the spread. Okay, so here's the warm-up dot plot. Let's see if I can zoom out a little so we can see them. So what happened to our shape? Did our shape change any?
It's the exact same.
It is the exact same except for the numbers. So what changed? What was the center on this one? What's the center on this one? 80. So our center changed. Did our spread change? We already talked about how the shape changed. But let's see. On the warm-up, what was the highest one? 99 minus 61. That would be a spread of what? 38. 99 minus 61. And here, our highest is 19, and the lowest is negative 19. So again, that's a spread of 38. So when we subtract the mean, or subtract anything from our observations in general, it changes the center, but it leaves the shape and the spread the same. So shape, maybe if my pen will work, and spread stayed the same. Our center went from 80 to 0, which happened to be what we were subtracting. We subtracted 80 from every score. 80 to the left. So down below, I summarized for you. So when we add or subtract a constant to our set of data, it's going to add that amount to your measure of center and location. So we just focused on center in general. We didn't talk about mean or median explicitly. But any type of measure of center is going to be moved by the amount you add or subtract. So the mean, the median, quartiles, percentiles, those are all going to be moved by whatever you're adding. And remember, you can think of subtracting as adding a negative. So when it says adding A can be positive or negative, or 0, which wouldn't make much sense, but. So they use the word add. So it changes your measure of center and location. It does not, excuse me, it does not change the shape of the distribution or the measures of spread. So we saw that our spread stayed from 38 in the warm-up, still 38 when we subtracted the mean. So measures of spread don't get changed. We focused on range, but it also applies to the IQR and the standard deviation of the data. Questions so far? So if you add or subtract something to your data, it changes your measure of center, nothing really else. Spread, shape, don't get changed. Now we're going to do the next part of finding the z-score, which was that we divide by standard deviation. And again, for the sake of nice numbers, we're going to say the standard deviation is 10. I want to say it was like 9.6 in actuality. Why couldn't I get that word out? Anyways, we're going to use 10. So we're going to fill in the table. So the first column, notice I didn't give it to you. Those were all the scores minus the means. So we had 61 minus 80, which gave us negative 19. And then we had negative 12, negative 8, 2 negative 5s, negative 3, negative 2, another negative 2, a negative 1, and a 0. And then on this part of the table, we had 3 zeros. 1, 1, 3, 8, 11, 15, and then 19. So you're going to take those numbers, the score minus mean, divide by the standard deviation. We're using 10, so we have pretty numbers. So negative 19 divided by 10 would give you negative 1.9. Negative 12 divided by 10 would give you negative 1.2. You guys are going to go through, find your score minus your mean divided by the standard deviation, and make your new dot plot of our z-scores, because at this point we have all our z-scores. answer up the board for us. Thank you, ma'am.
Okay, where? The second part one.
The negative 0.
Which one? Say it louder.
You forgot the negative .1.
-0.1. Oh, right there. I see it. You went -2 to 0. Thanks, Zach.
Sorry.
You're fine. All right. Let's see. So there's our warm-up. I'm going to cover up that label. And then here was our dot plot from when we just subtracted the mean. Sorry, I'm trying to make it so that it's just the dot plot. So, what happened to our shape? Shape stayed the same. What happened to our center? It is the same. Went from 80 to 0 and it's still at 0. What happened to spread? It was 38, 38, and now what is it? 1.9 is the largest and negative 1.9 is the smallest. So it went from 38 to 3.8. So what did we do? We divided it by 10. So, down below, what happens to the shape? Shape stays the same. Now, the weird one is our center. Center technically gets divided by 10. But what is 0 divided by 10? 0. So it looks like it stays the same, but you actually do divide your center. And we divided our spread as well. So down below, I summarized for you again. Can I move it up? So the effects of multiplying or dividing by a constant. Remember that dividing is the same as multiplying because dividing is technically multiplying by a fraction. So they are the same thing. Just like adding and subtracting are the same operation. So when you multiply each observation by the same number, b, whether it's positive or negative, it multiplies your measure of center and location. So like I said, the center did get divided by 10, but 0 divided by 10 is 0, so it looked like it stayed the same. It multiplies your measure of spread. Now, if it's a negative, it only multiplies your measure of spread by the absolute value of the constant, not by a negative. So if we divided everything by negative 10, our spread would be divided by 10, so it'd still be 3.8. It does not change the shape of the distribution. So now we're going to look at what this means in terms of homework problems and how you would apply it there. Can I flip? Right. This example says in 2010, taxi cabs in New York City charged an initial fee of $2.50 plus $2 per mile. So in equation form, the fare was found by taking 250 plus 2 times the number of miles you traveled. At the end of the month, a businessman collects all his taxi cab receipts and calculates some numerical summaries. The mean fare he paid was $15.45 with a standard deviation of $10.20. So what are the mean and standard deviation of the lengths of his cab rides in miles? So we have his fares and we need to solve for miles. So I'm going to do the mean on one side. Let's do the mean here. And then I'm going to do standard deviation on the other. Standard deviation. So the mean, which is a measure of center or spread. Mean is measure of center or spread.
Right.
No. Center. Tells you the average in the middle. Mean is the measure of center. Your measures of center, if you look back, get affected by adding or subtracting a number. So when we add or subtract something, it adds to the measure of center. So 80 went down to 0 because we subtracted 80 or added a negative 80. And then our measures of center get multiplied by b, our constant. So our mean, which is measure of center, is going to be affected by any operation that we use: adding, subtracting, multiplying, dividing. So we know his average fare was $15.45. So to find the average number of miles, we put $15.45 in for the fare, and we're going to solve for miles. What would be the first step in solving? Subtract 250. I was going to say think of miles as x. So first thing we're going to do is we're going to take away 250 from each side. Center is affected by subtraction. So when I do this, I actually do the subtraction. Those go away. That'd be what? 1345, 1295. Somebody with a calculator, double check me, please. Did I get it right?
Yep.
Thank you. All right, and then what would the next step be? We're going to divide by what? 2. And center is affected by division. Oh man. 95 cents, that'd be what? 647, 6.475. Yeah. I did 12 divided by 6, or 2, got 6. 95 divided by 2, I don't know, just 47 and a half. I don't know. Calculators weren't a huge thing when I went to school.
So you can do that in your head, but you can't spell effective correctly.
I said that in the beginning of the school year. I don't know the difference between effect and affect, so don't pick on me about it. Every year I have a kid tell me the difference too, and I can never remember. So apparently it's affect, correct?
This one, you want affect, yeah.
Thanks, Nate.
You're very welcome.
That is the mean number of miles. So he doesn't have a name, so I'm just going to say he traveled 6.47 miles on average. Miles on average. And apparently I can't spell traveled either, Nate. Traved. This is not my day. Traveled. There we go. All right. Actually, our oldest is extremely good at English.
How did that happen?
I don't know. And he actually enjoys the subject. Like, ugh. Like, seriously, kid? Come on. Standard deviation is a measure of, if this is a measure of center, this one is a measure of spread. And spread, affected, got my effect right this time. If we look back, our measures of spread, when we add or subtract a number, it does not change the measure of spread. But when we multiply or divide, our measure of spread gets multiplied or divided by the absolute value of that number. So this one only gets affected by multiplying and dividing, not the adding and subtracting. So we know his standard deviation for his fares was 1020. Where'd my green pen go? Like, what happened? So we have 1020 is equal to 250 plus 2 times the number of miles. First step in solving for miles would be subtract 250. But measures of spread, like standard deviation, don't get affected by subtraction. So we break the laws of algebra and we don't do this. And we just leave it as 1020. It's illegal in algebra class. It's very legal in statistics class when you're working with measures of spread. Thanks, Noah. And then to get miles by itself, we're going to divide everything by 2. Now, measures of spread do get affected by multiplying and dividing, so we do the division this time. Sam?
Where did 250 go
It just pretty much gets ignored because it has no effect on your measure of spread. So, Sam,
Yeah.
when we subtracted the mean score here on this first example, our measure of spread, the range, stayed the same. So it was 38 from the original data, 99 minus 61 is 38. When I subtracted the mean, my lowest became negative 19 and my highest became 19. So when I take highest minus lowest, it's still 38. So your measure of spread doesn't get affected when you add or subtract things. So standard deviation is a measure of spread. So when I subtract the 250, it's not going to change anything there. Because if I actually had the data and I had my highest and lowest, I would still get 1020 for my standard deviation. Did that help clarify?
Yeah.
So then we divide by 2, which measure of spread is affected by dividing. So we get 5.1 miles. Anybody remember how to interpret standard deviation?
Variation.
It is a measure of variation. Anna? Hold on. Alex, I can't hear Anna. Say it a little louder for me.
5.1 miles like above the mean.
That would be our z-score if we were looking at z-scores, but this is our standard deviation. What does standard deviation measure? Michelle? Yeah, this tells us how far away all our observations are from the mean on average. So I told you guys to start with the words on average. We expect I was going to say data, but the data is the amount of miles. So let's put it there. Problem. To vary from the mean. Am I still on the screen or am I below it? Thank you. Alex. Thanks, Maddie. Any other questions? No? Okay, move it up. We're going to look at this one, the other two. So we looked at this example before, but we're going to answer some different questions. So Mrs. Novard's statistics classes height distribution is shown in the dot plot at the right, along with the summary statistics from a computer output. So the number of data points, average, standard deviation, 5-number summary. So A says, suppose you convert the class's heights from inches to centimeters. 1 inch is 2.54 centimeters. Describe the effect this will have on the shape, the center, and the spread of the distribution. So to convert it from inches to centimeters, are we going to add, subtract, multiply, or divide? We're going to multiply. We would be multiplying by 2.54. Because let's say I'm 5'10", so that'd be like 70 inches, right? So if we want to convert my height to centimeters, we would be multiplying by 2.54 centimeters per 1 inch. So we're doing a multiplication problem here. So what effect does multiplication have on shape? None. Shape's going to stay the same. What effect does multiplying have on our center? It's going to multiply it by 2.54, right? So our center is going to be multiplied by 2.54. What effect does multiplication have on your spread? It multiplies it, so our spread would also be multiplied by 2.54. Questions on that one? So then B says if Mrs. Navard had the entire class stand on a 6-inch high platform and then had the students measure the distance from the top of their heads to the ground, how would the shape, center, and spread of the distribution compare with the original height distribution? So if she's having them stand on a stool, that's 6 inches tall. So my height would go from 70 inches to what? 76, because I'd be adding 6 inches to my height from standing on a stool or a platform. So we're looking at an addition problem. So how does addition affect your shape? It stays the same. How does addition affect your center? We're going to add 6 to our center. What does addition do to your spread? Nothing, so our spread would stay the same. Questions on that one? Okay, then part C says, now suppose you convert the class's heights to z-scores. What would be the shape, center, and spread of this distribution? So z-scores, how do we find z-scores again? What's that formula that I told you last week is never ever going to go away? Don't just memorize it and forget it.
Minus the average divided by
Thanks, Sam. I'm almost done. Just wait. Alright, so what's going to happen to our shape when we convert to z-scores? We're going to be subtracting and dividing. Stays the same. Thanks, Sam. So your shape is affected by nothing, really. Adding, subtracting doesn't change shape. Multiplying, dividing doesn't change shape. So our shape's going to stay the same. What about the center? It's going to be what? Which of those affects the center? Subtracted and divided. Thanks, Hannah. no. Am I off the screen? And then what about spread? Oh man, I messed up my color scheme. Sorry, that should have been in pink. What's going to happen with spread? Is it going to be affected by subtraction?
It's just
Just the division. Questions? Nate?
What's the advantage of the Z-score?
We're gonna get more into that on Thursday. By the way, quiz tomorrow. But it allows you, so my favorite example is SAT scores and ACT scores. In theory, they're supposed to measure the same thing, but they have such drastically different ways they score the test. So SAT's at 1600, ACT's at 3600. So if you have Z scores, you can standardize the scores, and then you could compare how a student did on the SAT versus the ACT by doing Z scores. Calvin? Yes, there will be a couple questions about what affects what measures the center and spread on the quiz.